All right, guys, so we're going to take a look at factoring now, and this is something you should have seen before, okay? So when we think about what we've done recently, okay, we're looking at the multiplication of polynomials, you know, a times b, a plus b times a plus b, okay, that's foiling. If we're doing the reverse process, right, the reverse process of taking a long polynomial and breaking it into smaller parts, right, that's exactly what we call, okay, what we call, oops, factoring, right? So all we're going to be doing is the reverse process now. So all that lovely activity we did today, multiplying all those factors together, we're just doing the reverse, which is factoring. So I want to just remind ourselves, what did we say that a plus b times a minus b was? Well, it was a squared minus b squared. Okay, that was a squared minus b squared. What was a plus b times a plus b? That was a squared plus 2ab plus b squared. And I told you these patterns were important. They're going to come back to play today. Okay. Then lastly, what is a minus b times a minus b? Well, that was a squared minus 2ab plus b squared. Okay, so let's take a look at that pattern, and let's see if we can apply those patterns to the factoring patterns we see here. All right, so let's take a look at the first one, x squared minus 9. Now, what do you notice about the x squared and the 9? Well, first off, there's no middle term, so it kind of looks to me like it's a pattern of a plus b and a minus b. There are no middle terms. And I'm also noticing that both the x term and the 9 are both square numbers. They're squared terms. Okay? So let's think about it this way. If I were to factor x squared minus 9, I could break that down into x minus 3 and x plus 3. What would be the a value? What would be the b value? We think about it in terms of a plus b, a minus b. Well, a would be x, and your b would be 3, right? Let's take a look at number 2, x squared minus 25. Well, I could think of that again as x squared minus 5 squared, meaning a, again, is x, and b is 5. So if a is x and b is 5, and we know that pattern of a squared minus b squared, we know that should factor into x plus 5 and x minus 5. If you know that a plus b times a minus b pattern, okay, it makes factoring it really easy once you identify what a is and what b is. So let's take a look at x squared plus 4x plus 4. Does that look like a plus b times a minus b pattern? Is it a difference of squares? Or is it a perfect square trinomial? To me, that looks like this pattern right here. It looks like a perfect square trinomial. So in this case, what's the a value? Well, a would equal x. And what's b? Let's think about b here. b would actually be 2. So if we think about what that would factor to, that would be x plus 2 times x plus 2. Where if you can identify the a and the b value, it makes factoring them very easy. So if we scroll down, you'll start to see some more complicated numbers. Okay, let's take a look at number 4, 16x squared minus 9. Again, I'm seeing 2 square numbers, or I should say 3 in this case, the 16, the x, and the 9. Okay, and to me, there's no middle term. That looks like it's a difference of squares. So what would a be? In this case, a would be 4x. And b would be 3. So if we know it's the a plus b times a minus b, I know my factoring should just come out to 4x minus 3 and 4x plus 3. Okay? So I'm going to take a little bit of time and try working through 5 through 9 here. Actually, you know what? Why don't we do 8 together? Let's do 8 together as well. So what pattern does that look like? A plus b times a minus b. Is it a difference of squares, or is it a perfect square trinomial? Well, I see this minus here in the middle. That's telling me the middle terms haven't gone away, so it has to be a perfect square trinomial. And since we have a minus in the middle, I know it's a minus b times a minus b. Well, let's see if we can figure out what the a value is and what the b value is. A, we're looking at this first term, 64, and x. What's the square root of both of those? Square root of 64 is 8. Square root of x squared is x, so a is just 8x. If we look at the b term, that's going to come from the last term there. What's the square root of y squared? It's just y. So if I recognize the perfect square trinomial pattern, I know this just factors to 8x minus y times 8x minus y. Okay? So be careful identifying the a and b, but then it should make the rest fairly simple. So if we scroll down a little bit, let's look at a couple others that look a little bit different, but in reality are very simple. Okay, so imagine I were to ask you to factor the expression 5x squared minus 40x plus 80. Okay, I don't see any perfect squares in the 5x squared or in the 80, but I do see that I'm able to factor out 5, right? So I asked the question, is there anything common to all terms? Well, I can factor out a 5, and if I factor out a 5, I get 5 times x squared minus 8x plus 16, and that, okay, again, you have to work to recognize, is one of the perfect square trinomial patterns. That would factor to 5 times x minus 4 times x minus 4, or really 5 times x minus 4 squared. You could write it that way as well. Okay, so let's take a look at number 10. So at first you may look at the 64x squared and say, well, 64 is a square number, x squared is a square number, so a is 8x. Well, if you look at it and combine with 8y squared, you'll notice that 8 is not a perfect square number, so we cannot immediately factor into one of our special patterns. But what you might notice is I can factor an 8 out of each term. So if I factor an 8 out, I get 8x squared, 8 times 8x squared, plus 2xy plus y squared. That hopefully starts to look like another pattern here. Okay, it may look like it, but again, if we take a look at that first term, that 8 in front of the x squared, you'll notice that you cannot factor it any farther. Sometimes you can go farther, sometimes you can't. All we can do there is take out the 8. Okay, let's take a look at, let's try number 12. If we take a look at number 12, what can we factor out of each term? Well, I can factor out a 6. So this becomes 6x squared minus 2xy plus y squared. The question I'm going to ask you, is there a number, or excuse me, does that look like a pattern that we've seen? Difference of squares are perfect square trinomial. You'll notice that both the x squared and the y squared are square numbers. So in this case, a is equal to x, b is equal to y. Is this an addition, an a plus b squared, or is this an a minus b squared? Well, because I have the minus 2yx, I know this is an a minus b, so this would just factor to 6 times x minus y times x minus y. Okay. So try continuing with 13, 14, and 15. See if you can factor those. Some of them will factor out evenly. Some of them you might not be able to go any farther, but give that a shot. Okay. Don't worry about sum or difference of two cubes yet. We'll talk about that in class tomorrow. But for right now, I want you to try to complete problems 1 through 15 on this worksheet here. And try to identify what the a value is and what the b value is on each one of these, okay? Come in with questions tomorrow, and we'll work it all out.